Hello everyone, now we are going to look at Form 4 Additional Maths Chapter 9 Differentiation. So before we start, I assume you already know all the basics of differentiation or finding the first derivative of any given functions or any given equations. So this part we are going to look at the gradient of a tangent at a point on a curve. Before we start, I want to point out a few things to show the relationship between the gradient of a tangent and differentiation. Okay, so now let's say you are given a curve. Okay, so this is a curve. And let's say this curve has an equation of y equals to 3x squared plus x minus 9. And a curve is made out of points. So there are a lot of points on a curve. So every point on the curve has its own tangent. Let's say for this point, and take for example the tangent, this is the tangent. So the tangent will be different for every point. For this point, the tangent will be this line, this straight line here, which touches the curve at only this point. For this tangent, this line, we call this line a tangent, has its own gradient. How do we find the gradient of this tangent which belongs to this point? Which is by using differentiation. So when we differentiate this given equation, for example, dy dx, we get 2 times 3 is 6, 2 minus 1, you get this, and then this one we get 1, negative 9 becomes 0, nothing here. So this dy dx here is the function of the gradient. So how do we know the value of the gradient? By substituting the value of x. And where do we get the value of x? From the coordinate of this point. If we are able to find the coordinate x of this point, take for example this point is 1, 2, just for example. So 1, the x value will be 1, meaning the x here will have a value of 1. So 6 times 1 plus 1 is equals to 7. So the gradient of this tangent has a value of 7. And what can we do with this value? We can find the equation of the tangent. Since we already have the point on the line and we have the gradient, we can substitute into the straight line equation, which is y equals to mx plus c. So the y, we can take the value of 2, m will be the gradient, x will be the 1. So in this case, we can find the value of c. So c is equals to 2 minus 7 equals to c. So c equals to negative 5. We substitute the values into the equation again. We get y equals to 7x minus 5. Then this equation will be the equation for this line, which is the tangent. And finally, if we can find the gradient of the tangent, we can also find the gradient of normal. How? So by using the formula, by using the properties m1 times m2 equals to negative 1, where m1 we take the gradient of the tangent, and m2 will be the gradient of the normal. So m2 equals to negative 1 over 7. So the normal line is the line which is perpendicular to the tangent. This is the normal. So the gradient of the normal, which is this line, has the value of negative 1 over 7. And if we want to find the equation, we just use the value of x and y and the gradient of the normal. We substitute into the straight line equation, then we can find the straight line equation for the normal. Question number 1. Calculate the gradient of the tangent to the curve. So again, gradient of the tangent means you are finding the dy dx. You are going to differentiate this, or you find the first derivative of this equation. So y equals to this, so dy dx equals to 2x minus 3 plus 5 it becomes 0. And then the x value, we just substitute because it's at the point, this point, with the x coordinate -1, so we just substitute into this. You get 2, -1 minus 3, you get -2 minus 3, -5. So this is the gradient of the tangent. So again, gradient of the tangent means finding the value of dy dx. Question number 2, find the equation of the tangent to the curve. So now we are looking for the equation. So to find the equation, the first thing is to find the gradient of the tangent. So to find the gradient of the tangent, we are looking for dy dx, which is equals to 2x minus 3. At this point, so the x value has this value, which is 2, -1 minus 3, -5. To find the equation, again, because the tangent is always a straight line, so we can use y equals to mx plus c. So we just substitute the value of 9. M is -5. Because m is the gradient of the tangent, which is -5. X is -1. Hence, we substitute the value inside, get y equals to -5x plus c, which is 3. Question number 3. Given that the equation of a curve is this, y equals to 12 over x, find A, the equation of the tangent to the curve at x equals to 2, and B, the coordinates of the point on the curve at which the tangent has gradient, -3 over 4. So first thing, A, the equation of the tangent. So in order to find the equation of tangent, the first thing we do, find the gradient of the tangent. So y equals to 12 over x. So gradient of the tangent is dy dx, which is -12 over x to the power of 2. So when x is 2, dy dx equals to -12. 2 squared, you get -3 over 4. To find the equation of the tangent, we need the value of y as well, but it's not given the value of y. Hence, we need to use this equation to find the value of y. 2, we substitute into this, you get the value of y, which is, so y equals to 12 over 2, which is 6. Then we substitute into the equation y equals to mx plus c. You get 6 equals to -3 over 4, 2 plus c. From here, you can find the value of c, which is equals to 7/1 over 2. So we substitute all the values inside. For B, you are given the gradient of the tangent is -3 over 4, meaning that the gradient of the tangent, okay, so I write here, gradient of tangent, which is dy dx here, is -12 over x squared. And this is given as -3 over 4. So it's -3 over 4 equals to this. From here, we find the value of x. So we just cross multiply, you get x squared equals to 4 or -4. So meaning that when x is 4, the gradient of the tangent is -3 over 4. When x is -4, the gradient is also -3 over 4. But we want to find the coordinates, meaning that we need to find the y as well. So we need to substitute 4 into this equation, the original equation, to find y. So 4, 3, and -4, -3.